How can you prove that two triangles are actually similar? Do you know any similarity postulates to prove them? Don't worry because we are going to teach you a few. Good day to each and every one of you. We are Group 1 and we are going to discuss about AA, which means angle-angle, and SAS, which means side-angle-side. Let us start off with AA similarity postulate. Later on, we will discuss on the second topic. The objectives for today's first topic is number 1, to define and explain the AA similarity postulate. Number 2, to identify the AA similarity postulate and illustrate examples. Number 3, to solve problems involving AA similarity postulate. Now, before we hop on to our main discussion, make sure to grab your papers and pens because we are going to warm up our minds and have a quick icebreaker. Are you all ready?
Hi everyone! Ready to escape the heat and dive into our video lesson? Let's kick things off! Before we delve into today's topic, let's get those brain cells buzzing with the little jumbled letters. Can you solve it? Correct! It's similarity postulate. Next is... And the answer is... Yes! Angle-angle. Well done for getting it right. Now, get ready to dive into our discussion in the topic of angle-angle postulate or AA.
You know the definition of the angle-angle postulate, or in short, AA in mathematics. AA is a rule in geometry that helps us know when two triangles are similar. AA says that if two angles in one triangle are the same as two angles in another triangle, then the triangles are similar. AA stands for angle-angle. It is a postulate used to determine similarity between triangles. Two triangles are similar if they have two corresponding angles that are congruent. So, why does it matter? Because it helps us understand when triangles have the same shape, even they are different sizes.
How to identify angle-angle similarity? Well, identifying angle-angle similarity in geometry is crucial for understanding and solving problems related to similar triangles, applying principles and developing critical thinking skills, laying the foundation for advanced mathematical concepts. To apply the angle-angle similarity postulate, you compare the measures of corresponding angles in the triangle. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. This implies that the corresponding sides are proportional in length, but not necessarily equal. The angle-angle similarity postulate does not guarantee that the triangles are congruent, only that they are similar. Now, the formula to calculate the area of similar triangles is the same as for congruent triangles. A is equals to 1/2 multiplied to B side.
Here's an example of angle-angle postulate, or let's say AA. The diagram shows that angle A is similar to angle B, angle B is similar to angle E, and angle C is similar to angle F. Since all three angles are congruent, it can then be proven that these two triangles are similar.
Do you now understand what's the AA similarity postulate? Now, I'm gonna test you because it's problem solving time. Here, we have two triangles who look similar, yet the measures of the other angles are missing. So how can we identify if the triangles are similar using the AA similarity postulate? Pause the video so you can try it on your own. To solve for the missing measurement of an angle, we have to add the two given angles and subtract it to 180 degrees. So why 180 degrees? That is the sum of all angles in a triangle. So let's take the measurement of angle P and Q, then add them, which will be 130. Next, subtract 180 from it. 180 minus 130 is 50. So the measurement of angle R is 50 degrees. Now we do the same thing to the other triangle. So we add the given measurements of the angles, which are 60 and 50. That sums up to 110. Then we subtract 180. 180 minus 110 is 70. So the measure of angle y is 70. Now that we have completed the missing measurements of the angles, we can now clearly see that they all have the same measurements. As the AA similarity postulate states, if the measure of two angles in one triangle are the same as the two angles in another triangle, then the triangles are similar. Here in our solution, we can clearly see that not only do we have two angles that have the same measurements, but all the three angles. So we can clearly say that it is similar using the AA similarity postulate.